Hey everybody, I found this interesting problem on a TV game show. It was a math, science, philosophy, history sort of competition game show. It was set in the Philippines, and the host was a gentleman by the name of David Seldrin, who did this back in the 80s, I think, also. And then he switched back. I believe it's called Bilyonaryo. Now, the question is, and I'm just doing this as an example, it's an arithmetic challenge, and there's a 5-digit number with a special property. If we place an extra numeral 1, that'd be, a lot of people call that digit in the US. At the beginning, we get a number 3 times smaller than if we put that numeral 1 at the end of the number. And if you take a look here, folks, this mathematical equation actually represents that in a direct translation. All the English gets converted into a math statement. Notice you have 1 at the beginning here. It's necessarily smaller than this one, right? Because a is going to be another digit greater than or equal to 1. So this completely describes the problem. And so we can use math manipulation, algebraic manipulations, arithmetic manipulations to actually solve this problem. But let's review how we actually do this. In these days of calculators, some people have actually forgotten to do this, I think. But anyway, the way you do this, and let's just write this, I'll write down the first step here that's going to kind of, we're going to imitate that with the letters actually. So 5 times 7 is equal to 3 times 10 plus 5, and that's important to write it that way. Okay, because you guys all remember it's called different things in different countries, but this 5 is called the remainder when you divide this product by 10. Okay, so you write the remainder down, 5. Okay, and then you do what they call a carry. And the 3 is the quotient. Okay, so then you do a multiply and an add here, and you get 3 is the remainder, because that would be 23, right? 3 is the remainder when you divide 23 by 10. Okay, and then you carry that 2, because it's 23, right? Here. And what do we get? Do we get 735? Let's hope that's correct. Looks right. You can do that one in your head. Now we're going to mimic that property, and I'm not going to, I've already done most of the work just in the name of time here. Again, an interesting problem. Mr. Seldrin, the host of the show, admitted to the audience, the TV audience, and the contestants, that this problem's too difficult, and it is. It's not difficult, but it's too difficult given the time constraints of a competition where there's cash awards. I think it's 45 seconds or something. I'm not sure how much time they had for it, but at least the way I did it, it takes much longer than 45 seconds. And so what we do is we effectively just mimic the steps. Since this is a 5-digit number, you can, I've written all the work down, so hopefully I don't have to say too much. But this would force the last digit to be 7. Okay, and you can tell that by inspection without any mathematical acumen, really, But you have to continue this process and use 7. You have to replace E with 7. So far we know that the last digit is 7. That's fairly quick observation. Okay, now you move along and you actually just replace E with 7. And now some people might want to try to do this all in one fell swoop. I think it's better to show each of the steps here. Okay, now in a similar fashion, we're going to determine that D is equal to 5. Now y'all, this Q stands for quotient. And notice that 3 times 5 plus 2 does give you a number that ends in 7, which is what we're looking for, right? Now you don't need to necessarily, we record the quotient because that's going to get carried, okay? Now in the very next step here, you notice this quotient 1 gets carried. This 1 is the same as this 1 right here, okay? So y'all, so far we know that 7 is E, D is 5. And if you carry on in a similar fashion all the way through, I won't bore you with all the commentary, you get down to here and you've determined all the digits. Okay, so I have A is equal to 4, B is equal to 2, C is equal to 8, 5, 7. So you actually get 3 times 1. And let me check again. What is it? 4, 2. Yeah, 4, 2, 8, 5, 7. Maybe I can remember that. We have 4, 2, 8, 5, 7 right here. Now 42857 is the answer they're looking for. Okay, I'll just write that down for clarity. This is the answer that they were seeking on this. I wouldn't call this problem difficult, but it's time prohibitive. Not a good contest question unless you give them more time. Okay. Now they do have math Olympiads where this kind of problem would be a very fair question and a nice question. So this is equal to, just in reverse here, 42857. Like that, folks. Okay, so again, this is the answer, but if you carry out this multiplication, you can almost see this one in your head. This is what you get. Another way to write this that perhaps is kind of revealing, you could write, let's see, you could write this as you could write it in quotient form, 142857 over 42857 Okay, I got that kind of messed up there, but that's going to be equal to 1/3 is another way to write that. If I manage to transcribe that without any mistakes, 14285742857 yeah, this is equal to 1/3, and some people like to actually look at it this way. But anyway, I hope you enjoyed that. The idea is to mimic what you would do with a known numerical example. And you're doing a lot more here. This looks like a fast process, but usually you can do single digit multiplications in your head very quickly and get the answer. Here, though, we were literally dealing with 5 unknowns, namely the digits that could take on the values 0 through 9. Okay, so anyway, that's the problem. This is the answer we got. And thank you, Mr. Seldrin, for producing an excellent show. And we look forward to future programs. Take care.